Hi everyone, welcome back to the channel and let me show you the problem statement for today. Let's have a look. So from our SD sheet, since we were solving DP section, this is the question that we are going to discuss today, min cost path. The question name is actually not very good because the question is actually about finding maximum path sum in a matrix. Let me just check if we are live. I think we are. Okay. Yes. Okay, so let's understand what does this question say. So this is not a difficult one. Okay, it's if you remember solving backtracking problems from our SD sheet previously, you'll understand this question in a much easier way. Okay, so let me tell you what is given in here and what you have to do. Let's take some matrix. What's the example? 348, 391. For example, 348, 391. What is the other thing? Let me tell you what you have to do in this. So this is a matrix that is given to you and these are some costs on that cell at which you are present. What you have to do in this question, that you can start from any cell in the first row. Okay, if for example I had a matrix like this, 1 3 2 5 10 and what else, let's take 4. Okay, and for example this was my matrix. Okay, fine. What you have to do, that you want to travel from first row till the last row. Here the last row is this, right? You can start from any column and reach at any column in the last row in such a way that the path that you follow, the cost on that path should be maximum. Okay, but the thing is that you cannot go in any direction that you want. For example, you are sitting here, it's not like you can go in any direction you want to. Let me just extend this array. For example, this is 1, this is 1. Let's make it simple. Okay, for example, this is your given matrix, right? Now have a look at the directions at which we can go. So they have told us that you can only move in these 3 directions, r plus 1 c, which means, I'll show you. So these are the directions. Let's understand what these directions are. What happened to this? Let me write it. R minus 1, R plus 1, C minus 1. Okay, so let's understand what these directions are. Suppose I'm standing at this cell, then you can go to the next. According to this first direction, you can go to the next row and keeping the column same. So I'll reach here. That is, you can go in down direction. This is D, right? Then the next direction that you can choose is, that is R plus 1 and C plus 1. That means one column, next column and next row. So you'll end up here. So this is which direction? This was down. This is diagonal direction. Okay. So I can say this is diagonal. Next direction that you can take is next row, that is R plus 1 and C minus 1. So for example, if I was here, then R plus 1 and C minus 1 would land me here. So this is again a diagonal direction, but left diagonal. This is right diagonal and this is your left diagonal, if I am right. So we have seen that they have given us just 3 particular directions in which we can move. So you can see that the directions are down, right diagonal and left diagonal, right? So now question comes down to the same thing that we have been doing for past so many questions, that for every cell you got 3 options. Considering there will be base cases, we'll see what that be, and there will be some constraints. That those are, for example, if you are at this cell, whatever directions you have, you definitely have 3 options, but will you be able to take all those 3 options? No. Why? Because when you will be taking this left diagonal, right, you won't be able to go, because that will be index out of bounds. There will be no cell like R plus 1 and which one, and C minus 1. So there will be no cell whose indexes will be R plus 1 and C minus 1, right? So that is something different. But yeah, now the whole question comes down to that every cell has got 3 options. You know what those 3 options are. So we will be exploring all those 3 options. So for example, if I'm standing at 1, right? I go from 1, I can take 3 directions, down, left diagonal and right diagonal. Okay, let me write the indexes here. This is 0 comma 0. So if you go down, you will reach at which index? We'll keep writing the path that we are taking to reach. Now let's say I just reduce this question. Let's reduce this question to 1, 3, 5, 10. Now let's take a smaller example and do a quick dry run, and you will be done with this question actually. Let's clearly understand now. So I am sitting at this cell. This is 0 comma 0 row column, right? So if I choose to go down, fine, then the path that I am taking is, in that path what will be the cost if I go down? So right now when I was sitting here, my cost was 1. If I choose a down direction, I go at index. Which index? This is row 1, right? This is 0, 1. So row 1 and column 0, 1 and 0, fine. And now from here, if I choose to go in all the 3 directions, down, left diagonal and right diagonal, will I be able to go anywhere? No. So this is your base case condition, that when you reach n minus 1th row index of your array, right, that's where you have to return your answer. So whatever answer you got, so from you won't be able to go at any of these options because that's a base case. Basically when you are here, you return your answer. So what answer are you going to return? So basically it's the path is giving you 5 as the cost, so you return your answer as 5. So this 5 adds up to what was the path when I was sitting here, what was the cost when I was sitting here, 1. So 5 plus 1. So basically I will add this later on. First I will collect all the answers from all the possible directions. So this direction gave me 5, returned me 5. Now if I choose to go to left diagonal, so from here going to left diagonal is not an option because index out of bounds will be there. There is no column like c minus 1. Will you find a column minus 1? No. So not possible to explore this direction. Let's go to right diagonal. So if I go to right diagonal, I'll reach at index, what will be my index? 1 comma 1. And the path from here, then I'll again try and explore all the 3 directions, but you will see that the base case will be hit because this is my last row. Last row means it is the 1th index in terms of row, so that's where I have to return the answer, because you cannot go, and your question says that you have to start from first row and reach till the end row. So the moment you reach at the end row, that's where you have to return the answer. Now your call will decide which is the maximum of all the answers that you have returned. So from here in your path, what cost did you take? So you took 10 for this. So this will return answer as 10. Now it has 3 answers. Answer from here is nothing, basically 0. Whenever you're not able to reach any path, you'll return 0 because it won't impact your answer. And now this call has 3 options, and it will decide which one to take by taking the max of all the 3 directions that it took: down direction, left diagonal and right diagonal, right? So you can see we are reaching to a recurrence relation, which is that whichever path we are at or whichever cell we are at, basically if I am considering this as some DP array I have created, for example, or you can take even a variable, for example answer variable. So answer variable task will be to store max of all these 3 answers and finally update itself with whatever cost that cell had. So it should add itself answer plus equal to that array's, that final answer that will be returned will be 11. Let's see, I don't know if that is the maximum answer. This was the answer when I actually started from 0 comma 0, but my question says I can start from any column from first row. So now actually my thing, now there will be a loop which will run over the entire row, only first row, to explore all the possible answers for each cell. So the way I explored answers for this cell, I will explore similarly, I'll explore it for 3. So if I start from 3, you'll have again 3 options. You can draw a recursion tree for yourself. We'll see what answer we can get. So from 3 you can actually go to 5. The answer that you'll have will be 8, 5 plus 3. And from 3 if you go to 10, you'll have 13. You see that so far what we got was 11 and 13 is the maximum. So basically for this particular grid, the maximum path sum would be 13. And how you will get? Now you know the relation. So recursion tree is clear. You know that every cell has got 3 options based on the base case conditions, that it should not exceed the boundaries, first thing. Second thing is, when do you return the answer? When you reach at the last row of your array. Now you can try a memorization approach, but your solution will not accept. video is lagging. Let me check, guys. Wait. Okay, so memorization won't work for you, at least for this GFG question. Let's understand the tabulation approach. Not even tabulation, actually. Yes, it is tabulation, but what I want to tell you that you don't need a 2D array like that. You need it, but you do not need to have an extra one. See, what we have done here is that I've taken an extra variable, this, right, this max pref. This value itself is updating its answer. Now let's understand what value we are given. Let me show you. This was your function. Let's understand this one. I'll take this and then I'll tell you. So this task will be done in big O of n square maximum, but let's see how. See, so what are we doing? Since I told you we are starting, we have to explore all the options from the first row, right? And here, while I was explaining you the recursion tree, we were going from top to bottom, right? This you can understand it in the bottom up approach. How is it? See, we are generating answers from the previous answers. So considering that this is my array, right? My array has these values already. I am going to start from the second row. For example, if I talk about this 1 3 5 10 1 3, or let's take our original, anything. What are we doing? We are starting from this row, and now we will generate our answer based on what answers we had from the previous cells. Okay, this row and this column, I1 J0. What am I going to do? I will assume that my maximum value is present in I minus 1 jth index. This right now my max pref is storing. My max pref is right now 1. I want to generate answers. Okay, so if, for example, I am starting from this direction, so this is I started with top down approach. Now I am telling you bottom up approach. So both the things you should understand. How we are solving this method from this method. When I am sitting here, I'll ask that I must have come here in by what ways? Either from the previous cell, previous row and same column, either I must have traveled down, or maybe I must have traveled diagonally to the left. How, in what ways can I reach 5? Or I could have traveled diagonally right. Okay, so if I had traveled from right diagonal, I must be somewhere at R minus 1, that is row minus 1 and C minus 1, right? But my check for index out of bounds will discard this option. In what other way can I reach to 5? I might reach to 5 from R minus 1 C, because that was also one possible direction, right? I can go down. So if I go down, from where will I go down? For that I should have been at R minus 1 Cth index. Now if I have reached 5 using my left diagonal option path, then I must be present at R minus 1 C plus 1, right? So these three options I will explore. I will check what is already present in my array at those indexes. Whatever will be the maximum, I will store maximum in max pref, right? And then I will add myself into it and update my array with that value. So let's see. So basically this array will start getting updated with the answers on the basis of these three directions. So when I am at this direction, I checked for 1. Okay, I will compare. So this check is for if you go toward to the diagonal left end or to the diagonal right end, left and right. So either ways, if you go to the left diagonal part, then your J column should be greater than 0, and if you go to the right diagonal part, then it should not exceed n minus 1th index. This is for that check. And then you check what is the maximum value out of error I minus 1 J minus 1, right, which is going to be this value, error of I minus 1 J plus 1, and the max prev, which is already 1. So out of them the maximum one would be 3, so that 3 will be stored in max prev right now, right? Okay. Now other one is if else if j. Okay, you checked for this one, you stored your max prev with that, right? Right. Now other option was I might have traveled right towards the bottom. For that I will check if I go above, my row should not exceed 0th index, right? So that is one check. I will check if when I go ARR of I minus 1 j, right? So I'll compare all the values. So for it the maximum would be 3, so I'll add myself into it, which you can see here, ARR of ij plus equal to max prev. So basically when you try to reach 5, the maximum path that you can take is 15, so this value will be updated with 50. Now you'll try the same thing for 10. You'll explore all the 3 directions. It's just the opposite approach as we discussed above. You try for all the 3 paths. You will see that this path will be denied because of index out of bounds. You will check 1 and 3. So 3 is maximum, so this value will be updated with 13, right? Finally, what we are doing in this option, so this is a smaller example, so we end up with just 2 rows, but if you take a bigger example, a grid of size 3 by 3 or more than that, you will clearly understand it. In case you have doubt, you still have any doubt. Okay, now I will iterate in the last row of my ARR, which I have just recently updated using these 2 for loops. So you see that now last row is already updated with new values. What is the maximum value? I will choose that and return my answer as 15 because I want to get the maximum path. So that's all about it, guys, and if you have any doubts, please let me know. Otherwise I'll wrap it up. Okay. So that's all, and we are done with this. Thank you everyone. Bye bye and take care. See you all in the next lecture.